Okay, this is part 5 in this series devoted to Improv Card Magic. Now today we will begin with 14 card packets. Okay, so I have a shuffled deck of cards here. And as you can see, we're going to look at something I haven't shown you yet. It's a kind of cool system for keeping track of the number of red and black pairs in such a way that you don't mentally become overwhelmed with the job. Okay? In fact, why don't we just take a minute and kind of explain this. So let's say we have these 14 cards here, and these are the colors of the cards starting from the top of the deck. So red, red, black, 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 and so forth. Okay, so here is a very interesting, simple system for keeping track of the number of red and black pairs if a person wants to go that route. So what you do is you associate with 2 red the number 10, okay? And then associate with 2 blacks the number 1. And then opposite colored pairs count as 0, so essentially just leave those, ignore those. Okay, that's probably the easiest thing mentally. So just skip those. So I see a red pair, so I think 10, and then I see a black pair, and I add 1 to it. So now in my mind I'm just thinking 11. Okay, so that's the number I'm thinking. Okay, nothing. Oh, I got another 10. Well, 10 plus 11 is 21. Come over 1. Oh, I got another 10 plus 21 is 31. And then over here, oh, I got a pair of black cards. So we add 1 to that, 31. So we get 32. So in my mind, I just need to remember the number 32. And remember that the tens place, the digit in the tens place, tells me how many red matching color pairs I have, and the ones place tell me how many black color matching pairs I have. So if I can just hold on to the number 32 throughout the performance, I can reconstruct the number of pairs that will either be red or black. Okay, so I thought this is a fun system to share with you, especially as the packet sizes here are getting a bit bigger. Okay, so as always, we need 3 random piles here of 14 cards each. So let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 3 piles of 14 random cards each. So what we'll do is we'll go ahead and just put these out of the way for a moment. And then if you remember, what we do is we pick up any of the 3 piles, actually. And then at the start here, just for the sake of the performance, my presentation here, we're free to look for an AMP mirrored or 2-cycle structure for the first pile that we picked. Now, for the last one, we're going to do something different that we haven't done yet in this series. Okay? So what we're going to do is, of course, they have 14 cards, and so what you have the spectator do is just kind of randomly flip these face up, face down, mix them thoroughly. Okay, and you can keep flipping if you want. Just kind of randomly mix them face up, face down, and then just, mix them together in a haphazard way. Okay, so just so you know, I'm not controlling anything here, and you wouldn't either. Okay, so then you just kind of clear these up like that. Okay, and then what you can do is just fan these out. Now, it is true, using an AMP structure would be the easiest for this little card flipping variation. And it just occurred to me you could use a similar sort of system that I just used for the black and reds. So for example, So we're still kind of practicing here, but for example, if we now associate, let's view it as an AMP, just to practice here. If you see a pair like this, where one's face up and the other one's face down, you can count that as a 0. It's kind of like being of opposite color. Okay, so it's very much analogous to what we were just doing. So this would be like a 10, right? A tens place. So we'd have 10, nothing, nothing, another 10, so it's 20 and nothing there. So if in your mind's eye you can hold on to the number 20, where this time the number 20 is telling you in the tens place, namely the 2, that there are 2 pairs of cards where both cards are face up. And since we have a 0 and that 20, that means none of the pairs that will reveal at the end consist of cards that are both face down. Okay? How about as a mirrored structure? Why don't we just practice here? So if you come on either end, so these are opposite orientation, we call it. So just instead of opposite color, think opposite orientation, face up, face down. Opposite orientation. Oh, these are both face up, the queen and the 7, so think of that as a 10. Next pair, opposite orientation. Oh, we have another up-facing pair. So it's 10 plus 10 is 20. And then we have opposite orientation, opposite orientation. Oh, that's interesting. So if we view this as either an AMP or a mirrored, you get 20 as our secret code for revealing how many pairs are face up, how many pairs are face down, and how many pairs consist of a face up and face down at the very end. Okay, well, since we're needing, if you remember, since we're needing a 2-cycle here, why don't we go with whatever nature gives us. Well, the 10 and the queen are related, and they're both face up. So think 10, come over 1, we have a pair of face down cards. So that counts as a 1. So that counts up to 11. Move 1 over. Oh, another pair of face up. So we add 10, that's 21. Come over here, we get nothing. Come over here, we get another pair of face up cards. So we had 21, 31. We get another pair of face up cards. That's 41. And then we get another final pair of face down cards. So 41 becomes 42. So why don't we go with that? I think that's pretty strong, actually. So if you want to think like 42, where the idea is, maybe I'll even write it out since this is kind of new here. So the tens digit tells you the number of, we'll say, face up pairs that will reveal in the end, and then the ones place, namely the 2, tells you the number of face down pairs. Okay, so these are just notes to help you out educationally within this video itself. You wouldn't show the spectator all of that information, of course. Okay, so let's go with that. I think that's pretty strong, actually. Because if you think about it, see 4 pairs plus 2 pairs, that's 6 pairs. That only leaves 1 pair. So we're going to match these up where all of the pairs have the same orientation within the pair, except for 1. That's pretty darn surprising, actually. Okay, so we're ready to move on here. Okay, so we have our 3 special piles, and we've made note of important information for each. Okay, the last one that we associated with a 2-cycle structure was something brand new. We did some card flipping. Do you remember that? We had cards face up, face down. Now, I don't know if you remember the special number that we just need to remember for this particular routine, okay? So I believe the number that we needed to remember, if I recall, was 40. Oh, yeah, that's what it was. It was 42. Well, how do you think I remembered the number 42? Can you think of 42 being kind of significant in the larger culture? Well, supposedly, in the Hitchhiker's Guide to the Galaxy, the number 42 is the answer to life, the universe, and everything. The problem is no one knows what the question is. We have the answer, but we have no question. Okay, so anyway, let me check. I think that's, yep, 42. So that's how I personally remembered the 42. I just thought, okay, that's silly. Is the answer to life, the universe, and everything. Okay. Now, of course, recall, our association here, right? So the 4, the tens place, was associated with a pair of face-up cards. The ones place was associated with a pair of face-down cards. And then any other pairings left over would be a pair in which there's a face-up card and a face-down card. Okay, so facing the opposite direction. Which is pretty amazing because once again, that means 6 of the 7 pairs will either be facing up or facing down. And then there's only 1 pair at the very end that will be facing opposite ways. That's pretty darn surprising, actually. Now, that will be the case as long as we remember to treat this as a 2-cycle structure and respect that structure as we convert it to other structures and preserve those as well, and perhaps and eventually get down to some kind of a fun reveal. Okay, so since this is a 2-cycle structure, we can convert it to a mirrored structure by performing a supercoat. Okay, so let's bring that up again. Let me bring up my table. Okay, so supercoat is on line 6. Line 6. Okay, so supercoat, if you remember, this is where you deal out half the cards and then you randomly stack those 2 halves. So it's like 1, 2, 3, 4, 5, 6, 7. And then you ask the spectator, how would you like these stacked? You want left on right? Okay, that's very good. So this kind of coding of the cards is guaranteed to convert a 2-cycle to a mirrored structure. Now, once it's mirrored, we can actually perform an LR shuffle or deal into 7 piles as well as a number of other shuffles that will preserve mirrored structures. So let's go ahead and just do the LR. And then as you're doing this, you can ask the spectator, would you like me to stack the left pile on top of the right or the right on top of the left? It's your choice. That's great. Okay, to convert it to an AMP, on the chart there, if you look at line number 15, it's a B11, so a Bessie 11. That will always convert a mirrored structure to an AMP. So recall how this works. This is where you take 1 from the top, 1 from the bottom, top, bottom, top, bottom, top, bottom, top, bottom, top, bottom, top. Last one goes on top. So this is now an AMP. And so what we're going to do is we're going to do this first shall be last, last shall be first, shuffle. So it's FL squared F. It's at the very bottom. It's line 25. And this particular shuffle is actually equivalent to a packet reversal. And that preserves all 3 of these structure types, which is really nice. So, so if you remember how that works, what you do is you begin dealing out the cards until the spectator says stop. And then you start dealing out into another pile, and maybe they say stop there. And then you deal into another pile, maybe they say stop there. And then you just keep dealing in this way until all of the cards have been dealt out. And then the key is to be true to the name, first shall be last, the last shall be first. You stack in the opposite order to which they were actually dealt. That's the only thing to remember for that shuffle. And all of that movement of the cards is equivalent to just reversing the order of the cards. Well, if you think about the structures of all 3 of these, reversing the order won't change the fact that an AMP is an AMP, or that a mirrored is a mirrored packet, or a 2-cycle is a 2-cycle. Okay, so this kind of mixing of the cards will preserve all 3 of those. Okay, now what we can do is one, I'm not sure if we've actually used it yet. It's called POE, so its abbreviation is POE, push off even. Numbers of cards, it's line 19. Okay, so since this is an AMP, as long as we respect the pairings we can randomly stack all of this together. So for example, push off even. You can ask the spectator for any even number between 2 and 14. And maybe they just say 2, so you push off 2 into that pile. Maybe they'll say 4 this time. Maybe they'll say 4 again, which is fine. Maybe they'll say 2 and then 2 over here. Okay? Now, the spectator this time is actually free to stack these in any order that they would like. So you can pick up this one, and then this one can go here. This one can go on top, maybe this one next, and then this one right here. Now, this is going to still be an AMP, amazingly. Okay? Now, a nice way to go from an AMP to a 2-cycle, if you recall, it's the RLR. Now that's line 9 on our chart to the left, RLR. Well, the first R represents random. So it's random up to a point. So if you remember how this works, it's a left-right shuffle. So you go left, right, and then the spectator's free to put the card on either pile. But you don't have to keep going left, right, left, right. Okay, so maybe they want it there, but you do have to build up one level at a time before you go to the next level. So this one, where do you want it? You want it there this time. How about here? There this time. What about there? Okay. This one over there. Okay, and this one here. Okay. Okay, so that's an RLR. And then with random stacking, this will now be a 2-cycle structure. Now, once it's a 2-cycle structure, you could do Chardelier shuffles or random cuts. There's a whole bunch of things you can do with a 2-cycle. But what I'm recommending here is a little different. It's kind of like the previous one here. So what we're going to do is we're going to Chardelier shuffle 50% of the cards, which is 7. And then that will give us 2 halves. And then the spectator is free to have us flip either half. Either half can be flipped. Okay, now for this kind of penultimate step here, I've just realized that the particular finishing for this routine, it works perfectly fine as long as card flipping is not essential to the whole routine. Okay, so I actually wrote this with just kind of a regular routine in mind. I wasn't planning on this. You remember how we randomly flipped the cards face up, face down? Okay, so I'm just noticing now that if we do what's here, we're going to destroy information that's important to us from the very start, given how we started this particular routine. Okay, so we're going to have to kind of modify this. This is a 2-cycle. Now what I'm wanting is I'm wanting mirrored piles. That's what I'm wanting. Okay, so one way to get that, actually, so in fact, let me just set this down and then I'll write it on the sheet so you can see. So what we're going to do differently than this, okay, that would have worked if all of the cards were face down and we went from there, okay? It's not going to work if the characteristic we have in mind involves whether cards are face up or face down, okay? So that's the important thing. So what we're going to do to get to mirrored piles is you can just do a deal, I'll write it here, 50%, and then just set down the remaining cards as a second pile. Okay, so why is that guaranteed to give us mirrored piles? Well, dealing 50% and then dropping the rest of the cards on top is a 50% coating. So if you look at our chart, line 5, a 50% coating converts 2 cycles to mirrored structures. Okay, but instead of stacking them to get a mirrored packet, we're going to just leave them separate for the final stage of this routine. Okay, hopefully that makes sense. So if you just deal in half of them into one pile and then leave the other half as is and set it down, those technically, when stacked together, would give you a mirrored packet, or before they're stacked together, they're actually mirrored piles. Okay, and that is something that we've talked about earlier. In fact, let me just bring that up since we kind of had to change things a little bit. because I decided to do card flipping for this final routine. Okay, so you remember mirrored piles right here? Okay, so what I was talking about is once you have a mirrored packet, the P down here is push off 50%. So if you have a mirrored packet, which we would here, and you push off half of them and set them down as a separate pile and the remaining cards as another pile, those will be mirrored piles, which is what we need for this swapping procedure. And this is a procedure we have actually used before, so you may recognize that element. Okay, so here we are where, if I haven't forgotten where we are, this is still a 2-cycle. Okay, this is a 2-cycle, and we're just doing something a little differently here, only because the 2-cycle structure from the start was in relation to the orientation of the cards being face up and face down. And if we had gone with this original thing here, it would have destroyed that kind of relationship. If we had just gone with like color matching pairs, things like that, we would have been just fine. Okay, so what we're going to do is we're going to deal out half of them. So 1, 2, 3, 4, 5, 6, 7. So instead of dropping these on top, which would now give us a mirrored packet, we're going to leave it as a separate pile. Well, these piles now are mirrored piles, okay? So every mirrored packet, if split in half, gives rise to, quote, mirrored piles. Well, maybe just to remind you, what are mirrored piles? This is where the top card here is related to the bottom card here, okay? And the same thing, the top card here is related to the bottom there. So there's kind of this mirrored relationship between these two halves of packet. Okay, and so now, because these are, quote, mirrored, we can actually do this really fun swapping procedure. Do you remember that? So since we have 7 cards all together, we have 6 free swaps. The spectator can allocate however they would like. So maybe they'll say, okay, perform 2 swaps on this half. So 1, 2. We have 6 total, so we have 4 more that we can do. So 1, 2, 3, 4. Okay, you just kind of set those aside like that. Okay, and now we have 5 swaps left. Okay, so maybe they'll do 3 here. 1, 2, 3. Very good. And then 2 here. 1, 2. Okay, and then set these down like this. Now, it is true, I just realized, it's not a big deal, but I just realized that we're going to see the end result doing it this way. It would probably be best, right before we do this, to go ahead and either like write out a prediction or have the prediction this time, maybe have this prediction written out, that there will be 4 face-up pairs and 2 face-down pairs. Okay, so have that written on a piece of paper and set aside or something, or state it before we begin the swapping procedure. Because if we actually go through all of this, we'll see what the outcome is, and then if you say, oh, well, in my mind's eye, I was seeing the number 42, and it means 4 of the pairs are face up, 2 are face down, and you've already seen that that's the case, right? Does that make sense? Okay, so some of this little tweaking at the end is because I decided to throw in this randomly mix the cards face up and face down and have that as characteristic of interest, okay? So before you actually do this, you'll need to let the spectator know that you can see the future, that you can see what's going to come from all of this, okay? So it's now, you know, so just assume now the spectator has been told by you that after we're done, somehow we're going to end up with 4 up-facing pairs of cards, 2 down-facing pairs of cards, and there'll just be 1 pair that has an up-facing and a down-facing card. Okay, so anyway, that's kind of important here because we're actually seeing it being confirmed in real time here. So to make it a surprising prediction, you need to let them know that you know what's going to now happen. Okay, what are we're down to 4 swaps, right? Total. So maybe the spectator says, okay, perform 2 here, and then 2 over here. 1, 2, very good. And then set aside this pair. Okay, and what's nice is if you've already stated there's going to be 4 up-facing pairs, 2 down-facing pairs, and 1 pair with opposite orientation, the spectator can kind of see how is he doing so far. He said we'd have 4 of like this face up. We have 2 so far, and then he said there'd be 2 face down pairs. Well, we have 1. Let's just see how this works out. Okay, okay. So we're down to 3 swaps, I believe. So how would you like these allocated? Okay, and what's really cool, I guess, in some ways about this, what makes it really powerful is if the spectator now knows what your prediction is for the outcome of this, they're going to think long and hard about how to allocate these swaps. They might even try to kind of look ahead and go, let's see, I'm going to allocate those numbers in such a way that it destroys his prediction. I'll show him, you know. Okay, so it's 3 swaps, right? So 1, 2 may be allocated there. It's a free choice by the spectator. And then 1 here. Set aside that pair. Oh, wow, look at this. Okay. So we've already predicted that there would only be 1 pair that's facing the opposite way, right? Different orientation. Oh boy, we cannot see any more of these. Otherwise, our prediction is dead, right? Okay, so what are we down to? We're down to 2 swaps. How do you want them allocated? You want both of them over here? Okay, 1, 2. Oh, good, look. Yeah, we got a down facing. We said we've seen in 2 up facing. We have 2 now, right? How would you like to allocate the remaining one? Over here. So we have 1 swap remaining, and you can allocate it on, so this one, okay? So set aside that pair, and then these are a pair. So how did we do? Our 4 pairs facing upward, 1, 2, 3, 4, and our 2 pairs facing downward, 1, 2, and is there 1 pair that's facing the opposite way? There is indeed. How in heaven's name were you able to do that? Okay. Okay, so I apologize for having to make that adjustment at the end. A lot of these performances, I make up the narrative on the spot in real time. And so the fact that I decided to kind of go with card flipping here, it would be affected by what I had done here. But if we had not done that, we could have gone through with exactly... Oh, in fact, let me just explain what this means. Charlier 50%. Let me just explain what we would have done if the cards were all face down and we were just counting like the number of red pairs or black pairs. Let me just explain that. So what is this? Okay, so assume this is a 2 cycle. That's kind of where we were relative to color or something, right? So what's the Charlier 50%? Well, what you do is it's a Charlier shuffle in which you move half the cards into your other hand. So maybe I move 2 here from the top, and maybe 1 from the bottom, and then maybe 1 from the top, and then 2 from the bottom. You just have to keep track of, like, you know, how many we have. We have 6. And then I would just need 1 more on the bottom, okay? So that gives us 7, okay? So we'd have 2 piles of 7. Well, it ends up that because it was a 2 cycle before doing this, if we now randomly flip either half relative to the colors of the cards, if that was the characteristic we went with originally instead of the orientation of the cards, this would now be set up. These would now be mirrored piles for which the swapping procedure would work perfectly. Okay, so I just wanted to explain that it would have worked just fine if I hadn't kind of changed how to present this last routine today here for 2 cycles. Okay, wow. Well, thank you for watching and for sticking to the end. We'll be putting out another video. It'll be a 16 card packet video next. And as you might guess, the packets are getting kind of big, so we have to get creative as to what we do with them. But I do want to remind you of something I said earlier in one of our videos in this series. Like with 16 cards, if you see something interesting with like the top 8 cards and the bottom 8 cards separately, there's nothing wrong with just breaking up that packet of 16 into 8 and 8 and then perform the kind of routine that we did with a packet of 8 cards, okay? Or you could break it up into 10 and 6. Those are packet sizes that we've used, right? So anyway, that's kind of where we're headed. I don't know if I'll use that particular principle or not, but we may. So thank you again for watching, and take a look at other videos on the Hidden Structures channel.